Hello everyone. Today we're going to talk about how to solve equations with variables on both sides. So far you've learned how to solve one-step equations, two-step equations, multi-step equations, but now we're going to add a variable on the other side of the equal sign and try to solve for that specific variable. Okay, so let's start with a quick example, something that I believe many of you could do. And that example will be 7x minus 8x equals 4x minus 17. So this is different than what you've seen before. As you see, we have x's on the left side, we have x on the right side of the equation. So what we're going to do is, similarly to what we've done with multi-step equations, is we're going to try to simplify each side first. So as you see on the left side, we have a 7x and a negative 8x, and they are like terms. So we will first combine those. 7x minus 8x will give us negative x, which will equal 4x minus 17. And you notice on the right side, you cannot combine those because one has an x and one has a negative 17. So what we're going to do now is we're going to do something a little different. Since there's an equal sign that is separating the two expressions, we're going to put both variables on the same side. How are we going to do that? We're going to use the properties of equality that we've learned with constant terms. Now we're going to do them with terms that have a variable. So you see there's a negative x on the left and a positive 4x on the right side of the equal sign. So what we want to do is get them all on the same side. So you could do this one of two ways. But what I decided to do here is I'm actually going to subtract the 4x. When I subtract a value from one side, I have to subtract it from the other. So I'll also subtract the 4x from this side. And then let's combine those. On the left side, we have a negative 1x, or negative x minus 4x, which gives us negative 5x. And we have, on the right side, the 4x and the negative 4x, the minus 4x will cancel each other out, and we'll be left with negative 17. Okay? Now you have just a one-step equation to finish. We're going to divide by negative 5, reduce if possible, and end up with our answer, x equals 17 over 5. Okay? I'm going to give you one more example, one with distributive property and with some fractions. And then you guys can try some on your own. So this problem, we're going to use y instead of x. Still work out the same way. 8y minus 6 equals 2/3 times a quantity of 6y plus 15. Okay, so as you can see here, we have values on the left and values on the right. Variables on both sides. What we're going to do is we're going to try to simplify like we've done in the past as well. And like I said, there's many different ways to do this. I'm noticing that on the left side, there's nothing I can do. But on the right side, there's a few different things I could do. One, I can distribute. And I'm going to choose to distribute this time because I know my variable, when I distribute, will allow me to simplify. So I'm going to distribute the 2/3 times 6y and the 2/3 times 15. The left side, nothing has changed. But on the right side now, when I multiply 2/3 times 6y, I end up with 4y plus 10. Okay? Now I have no fractions to deal with, so I can simplify this even further. Now, let's combine our variables. So unlike the last problem, now on the left side, there's nothing to combine because you have an 8y and a negative 6. And on the right side, once again, there is also nothing to combine, 4y and a 10. So what we're going to do is we're going to get the variables on the same side again. Okay? I'm once again going to choose to subtract from the right side 4y and end up with 4y minus 6 equals 10. Now I have a two-step equation that we've all learned how to solve. We're going to add 6 using the addition property of equality to get 4y equals 4, and finally divide by 4. And end up with y equals 1. Okay? So when you're solving these problems with variables on both sides, there's one issue that you come across. And that one issue is there are different answers than just one solution. Okay? For example, I'm going to show you 3 problems. Okay? First one here, 2x plus 1 equals x minus 1. Okay? This problem, as we've seen in the past, when we solve, we're going to put the variables on the same side. Subtract x to get x plus 1 equals negative 1. Subtract 1 to get x equals negative 2. And here, as you can see, there is one solution. Okay? And that solution is negative 2. But you can have a problem where, if we change this up a little bit, and we write this as x plus 1 equals x minus 1, we're going to work it out the same way, and we'll see what we come across. We're going to subtract x just like the first problem we saw. And now on the left side, we end up with x minus x. That becomes a problem for us, because those x's will then be eliminated, and we'll be left with 1 equals negative 1. And we should all know by now, and notice here, that 1 does not equal negative 1. So when you end up with variables being eliminated, and the numbers that are left are not equal, we say this is no solution. Okay? And there's one more possibility. We can have one solution, no solution, and finally, when we finish this last one, many of you might be able to see already, okay, is when we try to simplify this by subtracting x again, we end up with the x's eliminating on the left, left with 1. The x's eliminating on the right, left with 1. And now you can see that 1 does equal 1. What this means is that any value you plug in for x will make this equation true. We call this the identity. Okay? When every value works, these two equations or expressions are the same on either side. Okay? So we can also call this, the solution is all real numbers.